Okay, this is Leetcode 3174, clear digits. So we're given a string S, and our task is to remove all digits by doing this operation repeatedly. We need to delete the first digit and the closest non-digit character to its left, and return the resulting string after removing all the digits. So the walkthrough here is we need to loop through this string, and once we stumble upon a character that is a digit, we know we need to go to our left, and we need to remove the closest non-digit character. So in this case, we would have to remove this B from our string when we land on the 3, and then when we land on the 4, we need to remove this C because the B's already been deleted. And doing this, pretty simple to come up with the O of n squared solution. We could just use nested loops. We could have a for loop that runs through all of the characters in S, and then we could have a hash set that just marks all the indices that we need to delete. And whenever we land on a digit and we need to go to the left, we could have a while loop that goes to the left and finds the closest digit that's not already in our hash set. It can then add it to our hash set, and then at the end we can just go through S, and all the characters that are not in our hash set we can return as our string. And the worst case time complexity there would be O of n squared, because we theoretically would have to go through all n in the second nested loop because we're just marking them, we're not deleting them. And if we were deleting them, we would have to reorder the entire string. That could take at worst n times, so O of n squared would be the time complexity of that. So for the slightly optimized solution, or not slightly optimized, the O of n solution, what we would do is, instead of using while loops, we would actually use a stack. And this is a stack question, which are pretty popular in coding interviews. So it's definitely good to understand these types of problems. So to implement this stack, it's pretty straightforward. We're going to loop through again. We're going to need to loop through every character in the string, and we're going to need to check if each character is a digit or not. And each character that's a non-digit, what we're going to do is we're going to add that to our stack. So when we land on H in the 0th index, we're going to add to our stack, we're going to add H. When we land on C, we're going to add that as well. When we land on B, we're going to add that as well. So then when we land on 3, this is a digit, so we know this is a digit. So what we're going to do is we're just going to pop from our stack. So we know for sure that the closest value to the left of it will be at the top of the stack. So what we can do is we can just pop this from our stack and keep the for loop going. When we get to the 4, we can then pop the top of the stack again. There goes our B, there goes our C. We're not adding any of these to our stack. All we have to do is we can just return our stack. So that's the solution. That's the O of n solution. So the time complexity here would be big O of n. And the space complexity here, a little bit contested. I would say the space complexity is also O of n, with n being the number of characters in S. And the reason this is contested is because we are actually returning the stack. So sometimes people like to say that that's really O of 1 because it's just what we're using in addition to whatever our result variable is. But we're adding more. We theoretically could have to add up to n items if everything's a character. But then again, we would be returning that. So I think it's O of n, but you could also make a case that it's O of 1. We're not actually adding any more space. But yeah, that's the walkthrough. Now we'll get into the coding solution here. So in the coding solution here, we're going to initialize a stack. We'll set that equal to an empty array. And all we're going to do is we're going to go through the characters in S. And if the char is a digit, if a character is a digit, what we're going to need to do is we're going to need to pop from the stack. Else, what we're going to need to do is we're going to need to append to the stack, because we know if it's not a digit, we know we need to add that to our stack, because that's an alphabetic or alphabetic character. So we'll just add the char here, and then all we'll do is we'll just return our stack as a string, and there we go. That works. Now for the C++ solution. So what we're going to do for the C++ solution is we're going to do the same thing. Initialize a vector, an empty vector. We'll call this our stack, and then we're going to loop through our string here. And again, we're going to have a conditional here where if the character is a digit, so we'll say S of I is digit equals true. So if the character is a digit, what we know we need to do is we need to pop from our stack. So all we need to say is stack dot pop back. And then for our else case, we need to stack dot push back. So push into the back of our stack with our character here. Now, just for some C++, there's a way to speed this up, but just do it this way. I is less than the stack size I++, and we'll just initialize a string here. We'll call the string str, and what we'll do is we'll just append each character from the stack onto our string, and this is actually stir, yep, and then we'll just return the stir. We'll just run this to make sure I didn't mess anything up, and I did, and that's my Python true. There we go. And there's the C++. So pretty simple problem. Let me know if any questions come up.